So I wanted to make another little video here, this time focusing on mole to mass conversions, which has been the topic of most of the homework that we've been doing and classwork we've been doing this past week. So I'm going to focus on what was called Jerry's method in the mass ratio Pogel. So this is kind of a streamlined method for finding the amount of mass of some compound that could be created if you know the mass of either the product or reactant in that same equation. So to be more specific, just to refresh your memory, the statement of the problem here was that if you are given that the mass of ammonia, NH3, is 30 grams, and you're also given that there is a balanced equation involving nitrogen gas and hydrogen gas to create ammonia. So given these two pieces of information, can you predict what the mass of nitrogen gas is going to be necessary to create 30 grams of ammonia? Okay, so just to reiterate, we know the mass of the NH3 is 30 grams, and we do not know the mass of the nitrogen that is required to make this happen. So there's a few different ways we could go about doing this. And a way that I came up with that I was actually inspired when I was talking to some of the students today, some of you guys, people were saying that pictorial methods are helpful, and I totally agree. So I came up with this method that is very diagrammatical, involving the use of diagrams, and it's kind of like following a trail. So I'm just going to show you how it works. So I'm going to have a starting point where I'm going to say, okay, I know the mass of ammonia, NH3. I know this thing. And I want to eventually get to knowing the mass of nitrogen necessary. It actually doesn't matter which one is a product and which one is a reactant. The whole thing will be symmetric. But there's some steps in between that I need to figure out to get from, if I call this like just from getting from A to B. Okay. So one thing is I'm going to need to relate the mole ratios of these two things. The reason being, and we've talked about this a lot, but just because you have a ratio of moles of two compounds, that does not mean that ratio holds for the masses. And in fact, in general, it does not hold. So here, what we're going to need to do is we're going to, at some point, turn our mass of ammonia into moles of ammonia. That's going to be a stepping stone for us. Now, going from moles of ammonia to moles of nitrogen is not that bad, because we're just going to, and I'll do this in detail in a second, but we're just going to use the 1:2 ratio given by the balanced chemical equation to do that. Okay. So this will allow me to go to moles of just N2. Once I get my moles of N2, of my nitrogen, I can then convert back into a mass, and that mass will be the mass we're looking for. That will be the mass of the N2. So we have basically 3 conversions, actually, we have to do. And Rachel's method breaks this up into the 3 separate conversions, whereas Jerry's method does it all at once. And so if I wanted to do this all at once, I need 3 pieces of information. I first need, here, I'm going to need the molar mass of the ammonia. Okay, because that is what allows me to convert directly between the mass of the ammonia and the moles of the ammonia. And the molar mass of ammonia, well, you guys know how to do this now, but just I'll put it over here on the side. And H3 is approximately 17 grams per mole. Okay, so I'm going to need that to go there. Then if I want to go from moles of NH3 to moles of N2, if I want to complete this leg of our journey, if you will, I need the mole ratios, the 1:2 ratio. So, or I guess if we're going from NH3 to N2, it's really a 2:1 ratio. So that's just the ratio coming directly from the chemical formula. Okay. And then finally, if I want to go from moles of N2 to the mass of N2, which is what you want to actually find, I'll again need a molar mass, but this time it'll be the molar mass of the nitrogen gas, which if nitrogen is 14 AMU, then the molar mass of N2 is twice that at 28 grams per mole. Okay, so now if I want to, this is all that I need now, actually, to solve this problem. And I guess I need my starting mass, which was 30 grams. So this is 30 grams. And this is all the information we need in this little picture here. So I'm going to now go backwards. I'm going to start and say, okay, if I want the mass of N2, I'm going to set this equal to something, well, this is going to have grams, right? Okay, so this is going to be something with grams of N2. So to go backwards, I'm going to need the molar mass of N2. Okay. If I want to go from here to here. And this is where the dimensional analysis really comes in handy. So this would be my 28 grams of N2 per 1 mole of N2. Okay. Now, if I want to go from moles of N2, I want to go from here up here, I need to multiply by the ratio of moles between N2 and NH3. Now, how do I know which one goes where? Well, I want to be able to cross cancel. I want to be able to cross cancel these moles of N2 with moles of N2 there. So that must mean that I need to put my moles of N2 on top there, and then my moles of NH3 on bottom, like that. So you see how they're lined up here, like that, and they'll cancel out. Finally, if I want to go now from my moles of NH3 to get back where I'm starting with my mass of NH3, now I need the molar mass of NH3. Now, the thing is here, moles of NH3 are in the denominator here in this conversion factor. That means they'll need to be up here, which means I'm going to have to multiply by the inverse of the molar mass of NH3. So 1 mole NH3 per 17 grams NH3. I know it seems like overkill, probably, writing out all of these units, but we'll see that they are lined up just perfectly in just a moment. And then finally, our 30 grams. So our 30 grams NH3. So let's take a look at this beast of an equation here. So this allegedly is the mass of nitrogen gas. Okay, and let's follow the chain of units here. So moles of N2 here and moles of N2 there. The units will cancel out. Beautiful. Moles of NH3 here, moles of NH3 here, those will cancel out. Okay. Grams of NH3, grams of NH3, those will cancel out. And what are we left with? We are left with 28 grams N2 divided by the number 2 and the number 17 and multiplying by 30. So if I want to just simplify this, I could say, okay, this is 28 times 30 divided by 2 times 17. And then the only units that survived are grams and 2, which is exactly what I want. I want to find the mass of the nitrogen gas. So what does this work out to be? Okay, well, it's the same as 14 times 30 over 17. If I plug this in a calc here right quick, times 30 divided by 17, I'm getting about 24.7 grams N2. And that is indeed the answer. So, just to recap, going back here, the statement of the question was given a mass of ammonia that is produced, how much nitrogen gas was necessary to produce that? And we also used the chemical equation that was correctly balanced to use the mole ratios. And then I set up this little chart here where I said, okay, if I'm going from NH3, I need to go then to moles of NH3, to moles of N2, to then get to the mass of N2. Then following Jerry's method, you just follow this backwards, exactly backwards. And each step involves one conversion factor. And the conversion factors have to be lined up appropriately to get the units to cancel out, to then arrive at the 24.7 grams of nitrogen gas. And that is what has been called Jerry's method.